An intriguing new discovery on the Red Planet. It's confirmed that you can't talk on Mars. Be affectionately welcome to this new documentary. If this is the first time, I introduce myself. I am Engineer Hiddekel Morrison, and I appreciate you decide to watch this educational content, where we will know the technological deployment of the Rover Perseverance Explorer robot, with which it was possible to measure the speed of sound on the planet Mars. In an interesting explanation of how sound works on the Martian surface, where you can hear a real greeting from the Red Planet, with new data that will surprise you. From an engineer's perspective. Let's start. This robot, Rover Perseverance of the National Aeronautics and Space Administration of the United States, NASA, which is currently conducting important scientific research, touring the surface of the Red Planet. Among the many tools that this robot has, it has two microphones, which allow it to directly record the sounds of Mars. An international group of scientists determined the speed of sound propagation on Mars from sound samples captured by recording equipment aboard the Perseverance rover, which is used by NASA to study and explore the Red Planet. The research findings were presented at the 53rd Lunar and Planetary Science Conference, held in early March 2022 in Texas, United States. Thanks to the microphones and technological tools integrated by the Perseverance robot, the speed of sound in the atmosphere of Mars could be determined by measuring the propagation time of the acoustic signal produced by the laser beam emitted by the Perseverance, which traveled from the ground to the microphone of the Super-Cam. Let's see the measurement of the sound that was achieved on Mars and the explanation of why you can't talk on the Red Planet. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology. Thank you for contributing to the creation of educational content. Sound is the sensation or impression produced in the ear by a set of vibrations that propagate through an elastic medium, such as air. On the planet Mars, sound travels at a speed of 240 meters per second. Not only does it slow down than on our planet Earth, but also the different frequencies are not regular. When listening to music or having a conversation on Mars, the high or treble frequencies would reach our ears first and then the lower or serious ones, which are more noticeable. So it is impossible to speak on Mars as on Earth. According to an article published on phys.org, this means that communication would be extremely difficult on Mars, with different parts of speech reaching listeners at different times, making conversations sound extremely confusing. The sounds would be distorted for the human ear. On Mars, we would first hear the high frequencies, treble, and then the low frequencies bass would reach us, creating a kind of sound puzzle whose parts we would have to put back together to understand what we are hearing. So that you have a practical and real example, using a simulation software of how the sound would be heard on the planet Mars from NASA, this phrase that we hear like this on the planet Earth.
Mi nombre es Hiddekel Morrison. Llegó el momento de hablar de tecnología desde la perspectiva de un ingeniero. Gracias por el apoyo y seguimiento.
It would sound like this, if we were on the planet Mars.
Mi nombre es Hiddekel Morrison. Llegó el momento de hablar de tecnología desde la perspectiva de un ingeniero. Gracias por el apoyo y seguimiento.
When we hear a sound, what we are really experiencing is our eardrums vibrating. That vibration comes from pressure waves that travel to our ears from the source of the sound. To reach our ears, the waves need something to travel through, like air. Sound waves can travel through liquids and even solids, but most of what we hear comes from the air. Mars has an unusual atmosphere compared to Earth, with very different temperature, density, and chemistry. These differences would have three main effects on the sound that would be heard. Sounds made in the cold Martian atmosphere would take a little longer to reach his ear. With an average surface temperature of around 63 C, Mars has a lower speed of sound, around 240 meters per second, compared to about 340 meters per second on Earth. The sound level you would hear would automatically be lower on Mars. The Martian atmosphere is about 100 times less dense than Earth's, that is, there is much less of it. That affects the way the sound waves travel from the source to the detector, resulting in a smoother signal. On Mars, you would have to be much closer to the source of a sound to hear it at the same volume as on Earth. Mars' atmosphere, made up of 96% carbon dioxide, would absorb a large number of higher-pitched sounds, so only lower-pitched sounds would travel long distances. This effect is known as attenuation, a weakening of the signal at certain frequencies, and would be more noticeable the further you were from the source. Taken together, these three impacts would change the way you would sound in the atmosphere of Mars. Of course, if you were on Mars, you would have an additional limitation, and perhaps the most forceful is that for a human being to be able to be on the surface of the planet Mars, they must use a spacesuit to protect themselves from radiation and be able to have oxygen supply. Therefore, communication and listening on the planet Mars cannot be direct to our ears, it will always have to be through devices until the planet Mars does not terraform or become a planet Earth. NASA's Mars Perseverance rover carries 2 microphones on board, which are the first to operate on the surface of Mars. They have begun to capture the actual sounds of Mars and of the rover itself at work. According to scientific research published in Physics, the online journal of the American Physical Society, the composition of Mars' atmosphere, dominated primarily by carbon dioxide, adds another peculiarity to Martian sound: high frequencies are attenuated more strongly than low frequencies. Low frequencies, making bass sounds more noticeable. Consequently, when having a conversation with another person located meters away, we would hear it as if through a wall, and we would receive mainly the low frequencies. The study of the sound on Mars also provides data on the temperature. The recordings obtained can be useful to test the temperature of the surface of Mars. The speed of sound can be converted into temperature through various conversions and comparisons, for example with the speed of the wind. The researchers discovered that the temperature of Mars undergoes significant fluctuations. In the future, they believe that these measurements will lead to more research on the propagation of sound on different planets. That is why they hope that the next missions to Mars, Venus and Titan will include microphones, which according to specialists are the next generation of instruments for planetary research. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the engineer Hiddekel Morrison, and I invite you to meet again in a future installment.